All right, so just keep in mind that I'm in what stands between you and lunch. So the sooner we get this done, and then the other amount of pressure that I have is that I'm now following Remus and Dylan's presentations. I feel like I'm showing up with like stick figures and crayons. So hopefully we can make this work. So I'm David Schultz. I'm a principal consultant with G5 Consulting, and we're going to talk about applying BatchML, B2MML to a unified namespace. So I'm approaching this from the sense of the best part of a unified namespace is there's no standard. The worst part of a unified namespace is there's no standard. But what if there were? And that's what we want to focus on is there a standardized model where we can start exchanging information, that type of thing. I'm very old school in how I do presentations. It's cookie cutter, but to me, it's more around the information. So here's what we're going to talk about. How do we define a unified namespace? If you ask 10 people, you're going to get 11 different answers. We're going to talk a little bit about some messaging applications. I want to make sure that we all understand when we are exchanging information, there's a good understanding of how we want to approach that based on what it is we're doing. We're going to talk a little bit about ISA 95, everybody's favorite subject. I know it's mine. And then we're going to apply that into and roll that right into BatchML, and then finally end up with how does HiveMQ support what it is we're trying to do, whether it's telemetry data or transactional information, that type of thing. UNS definition. I think it's very important for a level set for you to understand how we think about what a UNS is. Does anybody recognize that quote at the bottom? It was Supreme Court Justice Potter Stewart, and yes, the topic was around porn. So thank you for bringing that up. It is. I was trying not to use that part of it, but yeah. So brilliant jurisprudence. I know, right? The guy was a brilliant judge, but what he's known for is I know it when I see it. So for us, what we're talking about is an approach to an event-driven architecture that uses a messaging application and a data ops tool that defines your models as well as the channels of exchange. Does that make sense to everybody? It's still a very, very vague, nebulous term, so we're trying to capture what does that mean. I was going to talk a little bit about event-driven architecture, but I realized that didn't necessarily enhance what it is that I was doing. But if you want a good source for what do we mean when we say event-driven architecture, there's a guy named Martin Fowler. He writes a lot of great stuff about it. He also has an article about what's known as Strangler Fig. It's an approach that we use for over time, we're going to replace the functionality of the existing system rather than just do this carte blanche, rip and replace type of thing. And we find that that works very well. So Martin Fowler is the person's name.
So, what do you mean by channels of exchange or
topics? We'll get into that. Okay. Topics. So if you think an MQTT topic, that is a channel of exchange, but in different applications, they may not call it a topic.
Not the pure protocol of which communicates.
Correct. Yes. Yeah. It's where are we going to exchange that information? What is that location? I would think. So from an MQTT standpoint, channel equals topic or topic structure, that type of thing. Single biggest problem to communication is the illusion that it has taken place. It's the idea when you send somebody a text. Oh, did you get my text? How do you know that that happened? And that's going to come into play in what it is that we're doing. So let's focus a little bit on some messaging patterns. So there's two ways we can do communication. There's synchronous, which is a real time. Think about talking with somebody on the phone. It's that in real time, we're talking back and forth. We're having a conversation. We're in sync with what's going on. And we want to use that type of information for a SQL query. And it's a consistent message for what it is that we're trying to do. So if I do a query and I'll get something back, I know that that's what's going to happen. Versus asynchronous. Oh, and I should say, if you want a copy of this presentation, just send me an email, find me on LinkedIn, happy to do it. Same thing with the images. If you want them, happy to send them to you. I have no issue with you having all the stuff. If there's value in things that you can do, please let me know. I want to share as much as I can for that. So I know that people like to take pictures. I'll just send you the whole thing, high-res images and that type of thing. It'll help. Again, they're stick figures and crayons, but there are some decent images there. So you'll find that I use a lot of 80s references because I was a kid in the 80s, and people look at me like when if I'm doing a transaction at a store and the credit card machine's taking too long, say, man, you must be on dial-up. And my wife just looks at me and says, they have no idea what that is. And funny thing, AOL just got acquired for, was it $1.5 billion? So, yeah, I'm trying to remember who bought it, but yeah, I was like, for AOL, but you've got mail, right? All right, so real fast, then asynchronous, not real time. We're not exchanging information. Could be text, could be email. That's pretty common, but think of a broker in this case. So if I'm going to send a message, something is going to send that message, but that's basically it. And then finally, there's what's known as eventual consistency. So in event-driven architectures, if I have a system, let's say it is my front end of where I'm doing ordering, and then I have my warehouse system, the ordering system is going to send a message, and eventually the ordering or the warehouse system is going to say, oh, I have a message, I now need to process something. So that's what I mean, the difference between consistency, and that should be consistency, not eventual consistency. It's there. So with a database standpoint, each database is consistent. They have the exact same information in real time. There's another pattern I want to make you aware of. It's the idea between orchestration and choreography. So if you think about orchestration, just think about an orchestra. You have a conductor that is leading the orchestra. They are bringing in all the parts. They are making sure that everything is exactly where it's supposed to be at the same time. You'll also end up with a messaging confirmation of, did you get the message? There's going to be some validation around, is the schema correct? Is the data in here correct? And then, of course, finally, there's going to be, remember that when you do orchestration, that requires higher resources when you want to exchange that. So orchestration, think about somebody's leading it. So if you happen to be in a 6th grade band and you're playing John Philip Sousa and the whole thing comes to a grinding halt, the leader of that organization or the conductor can bring everybody to a grinding halt. So I know that was a very specific reference that could or could not have happened. Same thing with choreography. So choreography, it's a lighter weight messaging system. It is I'm just going to send information, and whoever is listening to that information is going to, whoever is interested in it will then consume that information, but there really isn't any kind of confirmation there. There's really no kind of validation. It's a fire and forget. So if you're playing the Tin Man in 6th grade and you forget your lines, you're in trouble unless somebody else tells you what you're supposed to say, and then the show can go on. But that's choreography. It becomes a very decoupled system. And again, it uses lower resources. So when you think about a broker, that's going to be more of it's a choreography. So you're just firing information. So if you think about a workflow pattern, so I'm going to use some, what's known as workflow in this presentation. Basically, it's I have a message, I send it, and then there's the end of this particular workflow in there. This is really good for telemetry data. It's an asynchronous. It's more choreography that you're going to use for a broker. There's no retention of that message. I realize there's QoS2, so there's a little, the retained message within MQTT. But specifically speaking, that's not what we're doing. We're really retaining that message as long as we need to get it there. And really, this is going to be more of a pub-sub type approach. So I'm just going to publish information, and then other systems are going to subscribe to it. Oops, skip the slide there. First, it's a message queue or a microservice. So I'm painting a broad brush, waving my hands. I'm very generalizing on what it is that I'm doing here. But when you get into a message queue, this is what you want to use for transactional data. Transactional meaning there's an event that occurs. I need to send a payload out to some other system and they want to consume it. So that's going to be transactional as opposed to telemetry. I think Remus, we talked about that during your presentation. Telemetry is going to be time series data, SCADA data, those types of things. There is going to be an orchestration layer in there. So if you follow this workflow, what's going to happen is a message is sent. We're going to do some evaluation. We're going to ensure that this message is properly formed. It's going to have all the proper data that you need. And then we're going to ensure that it made it to its final destination, because you need to have those types of things. It's sometimes referred to as the CONNACK. And of course, it will retain that message until it is delivered. So that system, that microservice, that message queue type system is going to retain it until it's always there. It'll carry the message. So within this type of communication, you can do 3 different modes. There's push, which is I have information that I'm sending to you. There is the pull, which is you have information that I want. And then, of course, there's the pub sub. Again, you can do that through this type of mechanism as well, where you're just interested in I have data and I'm going to send it. And if somebody's interested in it, it's basically I'm going to raise the flag and see who salutes. That's really kind of the idea here. So now we're going to get into an ISA 95 overview. Quick show of hands. How many people are familiar with the ISA 95 standard beyond enterprise site area line cell? Understand what those methods of exchange are, that kind of thing. Excellent. That's good to see. So if you're familiar with XKCD, there is a 3 block strip and that's where that comes from. We need to develop a universal application. And then, of course, the future state, there are now 15 competing standards. So look up XKCD. It's really good stuff.
You sure it's not quarterly?
Right? Yeah, exactly.
I don't know.
I'll know it when I see it, right? That's all it's anybody that's ever going to remember. It's like, well, yeah, there was a guy who did a presentation, he brought up porn. I don't know what that was all about. Yeah, I know. Yeah. Fair enough. All right, so ISA 95, I think one of the biggest misconceptions around ISA 95 is, and we refer to it as the pyramid, is that this is functionally, or it's all about the function. What is the role of the system? What is it doing within your manufacturing environment? And of course, it's broken down to, is this secondly or sub-secondly data? Is this minutely data? Is this daily data? So that comes into play, but really it's about the function. So your enterprise system is going to be, think your ERP. That's something that is broad across the enterprise. You don't necessarily update it in real time. And then you get into that level 3 piece where now we need to exchange some information between our SCADA system and that ERP. So that's where we come into this level 3 type of thing. How you connect these systems and how these different systems will communicate with each other, it's not hierarchical based. And so I think really the takeaway from this slide is understand it's functional. It doesn't mean that you have to connect all of these networks. So don't, to me, it's don't use the automation pyramid represents similar information, not the same information. Purdue represents similar information, not the same information. Really the key takeaway is the function of the system and what it's doing, how you connect all this information through. That's the thing you need to keep in mind with that. So going back to the equipment hierarchy, within part 1 of the standard, there is what's known as equipment hierarchy model, and that's where you get that all too familiar enterprise site area line cell. Keep in mind that that depends on what type of manufacturing you're doing, whether it's continuous, whether it's discrete, whether it is batch. You will call them different things per the standard. And then of course, there's also storage units and storage zones. We're going to model those things at the same hierarchical level as we do our role-based equipment that's in here. Keep this in mind though, because I'm going to refer to this as hierarchy scope as we go through the rest of the presentation. What hierarchy scope is eventually going to turn into the channels of exchange. So you're all familiar with where UNS, where we have that enterprise site area line cell, that we will be using that throughout, especially we get into the B2MML, BatchML.
Quick question.
Yep.
On that slide, we have work center and work unit.
Mm-hmm.
And then, so depending on which processes that changes whether or not it's line or cell or production unit or unit? Or,
exactly.
So like if I was in, that's a continuous process, it would be enterprise site area, production unit?
Yes.
Okay.
Yeah. Generally speaking.
So the generalized version within ISA is actually work center, work unit?
Correct. Yeah, and just kind of a rule of thumb, work centers are generally going to be interacting with the level 4 system. Your work unit is going to be interacting with your level 2 system. A work center can have multiple work orders on it versus a work unit only will have the one.
Got it.
So some general rules of thumb of how to differentiate the equipment, but we're just trying to build in how is this information organized type of thing. So the ISA 95 standard is really interested in, so I left those graphics small because they were an eye chart no matter what I did. So I said, I'm just going to keep them as an eye chart. What we're interested in, and there's 4 types of operations management. So most people think of it as production, but it can also be maintenance, quality, or your material. So as you're moving or inventory. So you can apply the same models to all of those different types of activities which are in your plant. So again, most of us think of it in terms of production, but it can handle maintenance events. So like your CMMS, we can model all that within ISA 95. And then there's 4 types of definitions that we're looking at. So you'll find the number 4 is going to show up a little bit here. Just think of this as the 4x4 of what are the types of information now we're exchanging. The first one's going to be definition. So definition, if you think about your work instructions or if you're out fixing something, that's just telling you what is the thing that we're going to do. There's also the next piece that's called capability. We don't spend a lot of time modeling capability, generally speaking, because that only helps us with the next piece, which is the scheduling. But we'll come back to that. But capability just says, what are we able to produce right now? Are we limited by some resources? Do we have the material, the people, the equipment, and the physical assets to do it? So, but there's a capability in there of what are we able to do. Then there's going to be the scheduling. Those are also known as request. objects. So now that we're ready to actually make something, there's going to be an information exchange of I'm now ready to produce some product right now, and here's going to be the schedule for how we do it. And finally, there's going to be the performance, or the response objects. So think of the schedule and performance, or the request response. Those are basically what was our plan, what did we intend to do, versus what did we actually do. And when you look at most of your KPIs across an organization, that's really what you're looking at is what did we mean to do, how did we do, and just compare those types of things. Also want to talk a little bit about activity models. So once you get into part 3, this is now starting to take the idea of we have the definition, we have the capability, we have the schedule, and we have the performance. What do those look like in terms of the data flow? What are they affecting? What do they look like? Again, you're going to have the same colors of the definition. Once we get into the green section, we'll come back to that. That's going to be your level 2, what's actually happening on the plant floor. That bottom green one of the execution, that's when Jean-Luc Picard says engage. That's what we're doing. We're actually producing material, and then we're getting information back in terms of what are our response, the response data that's coming back, and then finally that'll get part of the performance and the response objects. So now we're going to get into part 2. So again, here's the number 4. When we talk about resources, we are talking about your role-based equipment. We are talking about your physical assets. We are talking about your personnel, and we are talking about your materials. You will find that pretty much everything in your plant that is a resource can be modeled in one of these. And that's why it becomes important. Keep note of these resource models you'll find through all the other information models that exist within the rest of the standard. So when I bring up the next eye chart, you'll have a good understanding of what I mean by that.
What's the difference between equipment and physical asset?
So equipment has a role. And physical asset is, generally speaking, it's something that's removable. So say I'm a part of a metropolitan waste treatment center, I have a pumping station. That is my equipment. It's performing a role to move water from a lower elevation to a higher elevation. Within that, there's going to be a pump and a motor. That's going to be your physical asset, because the physical asset could move when I'm doing a maintenance activity, and then I'm going to put in a new motor, but still the idea is that I'm moving water from a lower elevation to a higher elevation. Yeah.
Could you do like a one-to-one relationship between equipment?
Yes, yeah. So we're getting into the resource network of how you actually map those systems together. But when we get into if there's portable equipment, that's probably going to be still modeled as a piece of equipment, role-based equipment.
Like a forklift?
Yes. So forklift or an LGV or an AGV, whatever we call that. It'd be equipment. Yeah, it's performing a role, but the asset itself, I might have something called AGV1, but the asset itself is going to have an asset ID to it itself. So within the context of, say, I'm doing some biopharmaceutical type thing, I'm going to have a mixing tank. Well, that's going to be the equipment, but the impeller that I use in that tank, because of some metallurgy and that type of thing, that's going to be an asset. Exactly.
It can be abstract from the actual asset itself and more associated with the process.
So the equipment is performing a particular function.
Okay.
Yeah, that's you kind of get into the weeds a little bit of what's equipment, what's an asset, and that's some of where we just have to start making decisions on. ISA 95 is not something that it's very strict, and here's how you do it. There's the ability and be very flexible with what it is that you're calling things. But yeah, that's a fundamental difference. Great question though, because we get that a lot. So yeah, resource information network, even though there is in the part 2 of the standard, there's this equipment physical asset. That really, in my mind's eye, should be deprecated only because we brought out that resource relationship network of what that looks like. Yeah. All right, so here's the next eye chart. The things that I want you to focus on across the top, there's going to be some colored rectangles. They're very thin, but that's where we're going to see where we're going to do the definition, where we're going to do the schedule, and where we're going to do the performance. That's across the top. When you get into that middle section, the bigger blocks that we're going to dive into a little bit more, what you're going to see is there's blue and then there's yellow. The blue is going to be the part 2 objects that are the exchange of information between your level 4, level 3 systems, so between your ERP and your MES. When you get into the yellow area, that's going to be a level 3 to level 3 exchange. So just kind of keep that in mind of what we're going to look at. The other thing is you're going to see that little resource model image. And when I have that attached right next to a block, so what we're going to do is start with the process segment. We'll get into that. But what you're looking at is how that process segment evolves. So if you're familiar with Pokemon and how Pokemon evolve, as their basic form and their advanced form, that type of thing, think of your process segment. That's what its evolution is. When we get into that work definition, we'll spend a little more time of why is that not associated with an actual object. It didn't It didn't actually evolve into something. The process segment, it's the basic, it's the agreed upon way we make things from the ERP's view of the world. So I'm going to use a fictitious juice factory to explain some of these, but this is that I need you to make juice. So I'm going to have a mixing tank, and I'm going to have all the resource models that go into it, but it's a basic building block. You want to think about your process segment as this is the template that I'm now going to use for the evolution of all the other forms that it can take in there. But it's the basic template, how we've agreed upon the smallest unit of work. And it's basically, I need you to go out and make 10,000 pounds of, some particular of a juice in here. As that evolves, now we're going to get into an operations definition. So how it evolves is we're going to have the operations definition as well as that operations segment. So now what we've done is we've gone from a generic template that's just make juice on equipment. Now we're going to make red juice on line 1 using an operator and the stainless steel impeller. So we're going to get very specific. We're going to define what all those resource models that are associated with this overall operations definition. So template to something that's very specific, and that is how the process segment is going to evolve into that. Now we're going to get into the operations schedule. So now what we've done is we've started with this basic unit of make juice. Now we're going to make red juice on line 1 with all the other aforementioned resource models. But now we're going to put a schedule behind it. We're going to say, I need you to make it on this day type of thing. So in this case, the ERP's view of it is, I need this done by Friday. That's going to be the schedule. Between now and then, there's going to be a resource, the resource requests that are between now and then, I'm going to need you to commit to those types of resources all the way out there. So really, when you get into the operations schedule, operations request, and the segment requests or segment requirements, that's going to have dates that are associated with it. So that's really all we've done. Now we're going to get into the work definition. Work definition is a more abstract layer, but when we're in level 3, what this means is that's now the MES view of what's happening. So the ERP is wanting you to make 10,000 pounds of a particular product. Well, the MES is like, how am I going to do this? Because I have all these other requests of things that I need to make. I might break those into smaller units. So I might just make 10 or 2,000 pounds at a time. Well, those are now going to become work objects. And that gives me the ability to be a lot more flexible with it. The other piece is that when I make juice, there might be some other activities that the ERP isn't aware of that I still want to make sure that I track the work on. So maybe I needed to go do some kitting. I need to actually move some material from my warehouse into the production floor. Well, the ERP only knows that I need to make 10,000 pounds of juice and I need to have it back by Friday. My level 3 system is now going to go into the additional work that is required to actually perform that work. The reason why you don't see your resource specification attached here is that that's what the workflow specification is going to do, and the work master. If you want to learn all about the work master, that's a whole day in and of itself of what we're doing here. It will relate back to the operations definition and ultimately that process segment, but it's an abstracted. It's the work master is not an evolved form. And this is where, when you get into the work master, we're also going to be tying in those that part 3 where we're talking about the activity models. It's now actually going to tell us step by step of how it is that we're going to do certain types of things. But anyway, that is the work definition. Now you're going to see some commonality here between the rest of what you're going to see is now there's going to be the work schedule. So I've defined what it is we're going to do, all that material kitting on the material movement. We're going to make, say, 2,000 pounds of it. I'm going to schedule those resources from the view of the level 3 system or the MES. And you're going to see all the same type of stuff. You're going to have the work performance. Work performance is now, remember, we're going back to, we had what did we plan to do, here's what we're actually going to do, or here's what we actually did. So instead of line 4, we had to put it on line 3. So that was my equipment actual. Or you know what, that stainless steel impeller wasn't there, but so we used the costalladium impeller. So that comes in. So it just tells you what you actually did. And now you're going to start being able to look at some performance and some KPIs of what does that look like. So, and like I said, it's going to map to the work schedule. So these are mirrored objects. I have work schedule, and now I have my work performance. And now you're going to see the exact same thing. So the operations, the ERP, they were interested in the 10,000 pounds of that red juice on line 1. Here's what actually happened, and here's what we did. And these messages or this information will flow right from your level 3 system right up into your level 4 system as well. So keep in mind, you're going to have one request object generally speaking, you might have multiple response objects, meaning that 10,000 pounds is broken into some different production schedules and that type of thing. So just revisiting that model, what we've done is now walked through the evolution of that process segment and what it all looks like in the information models. I mentioned we don't talk about capability too much. That would be sitting in there between your definition and your the work schedule itself or the operations schedule. Also keep in mind that not every SIST or every plant is going to need that level 3 type information. So if you're familiar with the old Mad magazines where you had that cartoon and you'd kind of fold it and put it over on one, I know going old school for everybody, the yellow stuff, that's going to be that picture of I can fold it up and all I really need is operations models in there. I don't have to get into that work piece. Rule of thumb, we typically do anyway, just because it gives us a lot more flexibility going forward. So that is around 800 pages of ISA 95 crammed into here 10 minutes. So no go me. A little bit more. So here's some things that what I find are people not aware of. So when you get into part 5 of the standard, and this is where we're going to get into the verbs. And remember we were talking about some of the different types of communication in terms of how do we exchange information. What part 5 is going to do for us is it's going to tell us, is this a push process? And so if I'm now sending you information, I'm going to use the verb process, and then you're going to respond back with the acknowledge. I got the message. This is going to be something that can be done asynchronously, but we're going to use like a messaging queue to ensure that something like that happened. And this is where we're going to get into the what I mean by when we talk about the message queue in a microservice, that type of thing. This is going to happen in those types of relationships. Or I can do a pull. So now I'm the operator. I need to get my new schedule. So I'm going to use a get show. Those are the verbs that are associated with that type of messaging exchange. And then also within the standard, we actually can do a pub sub as well. And that's where you're going to get the sync add, sync delete, and then sync change. So those are the various messaging types you can handle. What the verbs inform you of is what is the pattern of this communication, and then as I'm using it, how do I want to affect that overall messaging queue itself. Does anybody recognize the cartoon character? Schoolhouse Rock. Yes, thank you. Thank you. Again, 80s references, I'm all about it. All right. So now we get into part 6 of the standard. So we just talked about the verbs. These are called standard topics. They'll generically be referred to as the nouns. Now we're going to start taking all of those information objects. So we have all of our resource classes. So remember the resources, your equipment, your physical assets, your personnel, and your materials. We're going to have those as a model, and we can exchange that. We're going to have all of your lots and sublots. So that's something we haven't spent. I didn't really talk too much about that, but those are all going to be models that are available to you as far as these patterns of exchange. And then, of course, there's all your definitions, your capabilities, your requests, your schedule, and your performance and your responses there. And then we're also going to have a workflow. So when we get into that workflow specification, there's going to be information about that where you can now exchange all this information. What you see on the right is the recommended approach to the topics or the channels that we're talking about in a broker, but generally we're going to talk about what is the system that's here, and there's a lot of ways you can approach it, but typically the way we approach it is like, what is the system? Is it my CMMS, my MES, my warehouse management system? What is going to be the owner of this particular data? I version it, and then I'm going to use that hierarchy scope, remember enterprise site area line cell, and then I'm going to use the topic, that is the noun, so that's one of these objects here on the left, and then I'm going to use the verb. Is this push, is this pull, is this pub sub? And how do I want to handle that? So now one last piece to the part 6 of the standard is, well, my system doesn't support ISA 95. What do I do? Well, no problem. We've got you covered. We're going to take your core system. We're going to convert that into the structure. In this case, could be a JSON or an XML. We're going to assign the right names to it. So now we're going to start exchanging the similar types of information, and then we're going to run it into the channel. The other system will consume that information and unpack it and dump it into its system itself. Hierarchy scope becomes very important in this type of exchange because we want to ensure, as we've learned within a UNS approach, is we want to make sure that when the data is taking place or when the data is transacting, that we have the ability to know where exactly is this, what equipment is this message relevant to, and that type of thing. So you'll see that as well. So now we're going to get into B2MML, BatchML. If you're not familiar with the ISA 88 standard, this is where we're going to match it together. So just real fast, ISA 88 was generally geared toward batching systems, but the ways you can model it approached or can be applied to any of those. So don't get too far into the weeds, But really what I talked about at the very beginning is when we define the UNS and the approach, this is where we're going to do our data ops. So this is where we're going to model the data and the channels of exchange, but this is how we want to now handle it with a unified namespace. So as I said earlier, but what if there were, this is where it's, I think, all going to come together. So this is if you were to map ISA 95, and that's going to be, remember all the blue, that was our level 4 sys stuff. We have the yellow in the middle, that's our work, some work objects. And then on the orange on the very far right side, that's how they map into your BatchML standard. So I'll just let you look at this rather than walk it all through, but you can see we're going to have all of our same definitions. We're going to have all of our same schedule request, and then we're going to bring it back with all of the performance and results. How did we actually do mapping that into what's happening in BatchML? Again, don't think it's, oh, well, we don't do batch, it doesn't apply. They can be abstracted away. We're going to call it something that's relevant to batch, but what we're getting at is we now have a common way to exchange all of the information all the way down to level 2, level 3, and level 4. So revisiting our activity model, you can see now between all of those yellow areas, we're going to use the B2MML. That's going to be the message structure of how we're going to exchange the information. Dispatching and that detailed scheduling is also going to use B2MML. Remember, once we get into that green area, if I'm ready to start a production order and I hit the word go and I need to download a recipe, that's going to be a BatchML object. So we can do those types of things. And then finally, once we get all that information back up from the plant floor, from the level 2 system, we're going to use BatchML objects again, and then we're going to finally do all of our performance and all of our analysis, that type of thing, using a B2MML payload. So that's how B2MML, BatchML work together to ensure that we're getting all the information down. So what does this look like? I have struggled to come up with a good way to show a JSON object on a screen. I've left out a lot. Generally speaking, when we're doing data models, we're going to do an operations schedules, operations performance. When we're in the level 3 system, we're going to be using a work schedule and a work performance. And then finally at level 2, it's general recipe information. That's where we dump down the data itself, or a batch production record. And that can handle events. It can handle status. There's a lot of things that are done. So what I've basically built in here is it's a work schedule that you now see has a work request that has a job order. So the job order is the process segment evolution within the job request information model. And now you can see I have, an ID, start time, end time. Remember that work type here is production, but there's 3 other work types we can do. Remember, it's maintenance, it's inventory, and it's quality. We're going to have that in there as what the value of that key is, bless you. And then we're going to have our job order parameters. I'll come back to that. But now you're going to see all the resource requests that we're going to have. I need this equipment. I need this physical asset, these personnel, and those arrays or lists. Those are going to have JSON objects within it itself. And we can get into the weeds itself. When you get into the process parameters itself, what that's referring to is a value that you want to measure or do something with that doesn't fit into those resource models. Very common way is if we're calculating OEE, we're going to use a process parameter that says, what is my theoretical rate or what is my standard rate? That's going to be something that would be a piece of information in there. So that's what it is. But now here's a very good standard way of I can start exchanging this information through it. So we talked about transaction channels. So what we're looking at here is this is going to be how we model the UNS for transactions. So the very top level topic is going to be the source system. We're going to version it. So that came up earlier. How do we version this type of information? We're going to keep the hierarchy scope in there. And then we're going to say, here's the material actual, and then process. That's the verb. I don't have the acknowledge in here, but that gives you a sense of what it looks like if I'm doing transactions through an MQTT broker. This is what it's going to look like. Again, there's going to have to be some data orchestration to ensure that that message got there, if your application requires it, that type of thing. Versus telemetry channels, if you've seen the movie Spaceballs, what you're seeing now is happening now. Real-time state, that's what we're doing. This is going to be that information. But you can see that I also have some of those ISA 95 information objects that are associated with that. Because right now I know currently in my production, I know what it is that I'm doing, but what's that job order? What's my material ID? All the resources will be there. What was my beginning start time, end start time? That's all there, or I can see in a storage tote what's in that tote right now and some of the information that is associated with that. So that's how these models get mapped back and forth. I'm going to take a pause real fast. Are there any questions about what I just went through, or should we just wait till the end? Okay, you got a question.
Just a quick one, yeah. So on the previous screen where you're showing system at the top, so we've explored various patterns like this with some of our customers over the years. I'm a HiveMQ, but that doesn't matter to this question. The biggest challenge we've run into is that doesn't work particularly well with MQTT in the sense of, for example, if I'm trying to use wildcards. If I want to set a wildcard for all of that warehouse, and I'm trying to move data as a wildcard format, I now have to create a sub-wildcard for every subsystem, because I can't just use, say I want to move every data point related to warehouse as an example. I now need to do, for each system, a wildcard for warehouse.
Yes, yeah, and that's by design. This is an approach. Yeah, exactly. Of how do you want to segment those systems off? It doesn't have to be the warehouse management system. You can call that something else.
Sorry, but I think my question is, do you encounter that issue where if I want to move everything related to warehouse, but I have data that's in my warehouse management system and my quality management system, whatever else it might be, I now have to create multiple wildcards.
Yes, yeah. So you'll do that, but how you're going to affect that is that when that transaction occurs, you're going to know, or you're going to be able to relate those two pieces of information together. Yeah. So to me, it's allowing people that are only interested in your warehouse management system. So, because the flip side of that is if I park all that information out below in my hierarchy scope, now I have to go through all of my different hierarchies of all that equipment just to see my ERP exchange or my MES exchange or my CMMS exchange, those types of things. So you have Coke on one side, you got Pepsi on the other. You know, I'm an RC guy myself, but hey, you know, it's not kidding. Yeah, very good. So yeah, so you'll end up with two different, what you got, Zach?
So the WMS, the root topic there, that's sitting alongside your enterprise.
You're going to have two different namespaces of that hierarchy scope. We've spent a lot of time on how do we version blue stuff, the blue data.
Send the payload into this WMS, and then behind the scenes, it then maps it into your traditional UMS?
That's the orchestration piece. So if I were to take a look, so what I didn't talk about here is that data ops piece. If only there were a really good data ops tool that would model data and exchange it on a channel, that'd be brilliant, Jeff. I mean, that would be something else. But that's where it's going to come from. Is you're going to have that exchange. You're going to have this orchestration piece that is going to slice and dice that data, and it will then present it to your level 2 data when it makes sense.
Right.
When it's there.
As a
Yeah. Yeah. What we'll do is we'll call that we model that as a work directive, meaning I need you to now go do this thing. That's where that model will happen, where it'll take the information and dump it down in your level 2 system, so you can see what the real-time information is. That's Jeff. I know, but I called on you. It's kind of my own fault.
On the slide that was advanced before this, I noticed that you had them broken out into like separate topics.
Oops,
Sorry, after. For some of these scheduling things, you know, a lot of times those transactions need to be processed like apoply. Are you merely just relaying this just so that like any system can observe what's happening on the actual authoritative transaction?
Correct. So your business logic is going to be written around what's the intended system. That's part of that orchestration piece, but we want to expose that transaction. So instead of doing a point-to-point, what we don't want to do is just limit that. Something else may be interested in what's actually happening here. So that's why we want to expose it here.
So the actual handshake would be like more of a complex data object.
Correct. Yeah, exactly. And then, of course, we talk about, do we want this to be done synchronously? Do we want it to be done asynchronously? Well, here's the beauty. I may just decide when I push that schedule down, I do that synchronously through some kind of API call. That said, other systems may be interested in when that occurred. So guess what? You can do both and actually have this present out here. Here's my process acknowledge type of piece. So when you get the response, you're now going to know, okay, yeah, this got the system and that type of thing.
What would justify a V1 to V2 type upgrade?
Schema change.
Okay. Like adding a column or just like a wholesale change?
So when we're using B2MML and BatchML, that is based on a standard. That standard could get updated. It's in its 7th iteration right now. So if you are now using version 6 and version 7 came out and you decided you now want to take advantage of some of the capabilities of that new version, then you would want to do a version change because that may be a little different. That's why you're going to version it.
If you go from 6 to 7, the clients
6, 7.
Sorry.
Sorry, and edit that F-bomb out. I didn't mean that to be there.
Go from 5 to 6. Clients that are subscribed to 5 stop getting data until they realize
That's part of it. So now we're into what's known as a data contract, which is when I send this information, here's where I'm going to publish it. If you change that, there's now a change management exercise of when I go from 5 to 6, what does that mean for the rest of our systems? If you version it, that means you can now have the new systems that need to take advantage of that new information on 6, where you have all the older systems that are still on version 5.
So
Right.
someone is publishing to both 5 and 6?
So we have the authoritative record of what system is going to use it. So think of this in the terms of I need to go from version 3 to version 4 of my software application, or I think we talk about Ignition here. If I need to go from 8.1 to 8.3, when would I do that? What does that look like? Type of thing. Compelling reason would certainly be one of those, or there's some functionality you want. Same type of thing here, but stuff that's still sitting on 8.1 that stays on 8.1 until you're ready to roll out to 8.3 for that particular application.
There's also backwards compatibility that goes with it, where you may have cases where you have a bunch of sensors publishing to version 1 of something. You're not going to change all of those sensors into version 2. What you can do instead is have your application have a different version 2,
Patch it.
but patch it to where it consumes it does a backwards compatibility for version 1 data to then move it into version 2.
Interesting though, as you version your namespaces, keep in mind how important neatness is. We all said, don't worry about getting your namespace right because you're going to change it 100 times. Imagine what it might look like 5 years from now when there's 1,000 versions in your broker and you don't have the ability or knowledge as to who's consuming which version. It gets out of control fast.
Mm-hmm.
You better think that through.
So that's coming back to version. I would not expect to have like version 27 after the first year. This is where that schema itself is abstract enough that most applications you can handle it right now. Dylan. So to me, I would call it red. Yeah. And then blue is going to change a little bit. So this is where we get into data governance, and I have to do the tension, right, between innovation and governance. So this is going to be governed, where your blue data is not necessarily, but there may be aspects of that blue data. And I guess something I probably glossed over a little bit when I did my, I thought I had it. Oh, you know what? It comes in an L later. Oh, no, it's right here. So I use assets. So assets to me, or what I'm defining is this is the level 1 view of this is that blue data. But when I get into equipment, I call it equipment. It's very similar to the asset itself. So asset edge, raw, however you want to call it. But we do in equipment because now we're going to do some exchange. That's going to be the red data that maps very easily to the blue data type of thing. So if you want to, so asset, think of, if I change out my asset and it has a different data model to it because it's a new improved pump, I still want to be able to send it set points and get its actuals coming back. So that has to be, you have to map that type of stuff. But this is that management of change. Just don't do things willy-nilly. It's the governance piece that sits in there of the thou shalt, thou may. And of course, I still do functional informational. Yeah.
In this picture here, I assume that some of the data is updating at different rates.
Yes. Yeah, so all my telemetry data is going to be updating in real time. So if all of a sudden when I'm done with that particular, say, material movement, that's where this is coming from, it's going to update where I'm going to know the end time. But on that transactional side, it's going to be publishing or be subscribing to that information. If somebody hit the button, now I'm going to take that payload and it's going to get written back to the database of my MES system, where it's going to get persisted.
But how it's displayed here, I assume work center actual end is so actual end is part of the topic, and the payload will be the timestamp. So
Yes.
I have to. How can I make sure that the job order is aligned with the actual start? So I have to subscribe to all these topics instead of receiving a compact payload describing all the context and the information order.
Yeah, so there's two things that's happening here. One of them is just going to be the telemetry when somebody entered or whenever somebody stopped the production on something. That's going to show up as a state on the line. But there's a BatchML payload that will now be associated with it's an event that there's now a status. So you have status that is about the work order itself. You'll also have the state that is about the equipment. So those are two of the tags in that key value pair that are there. So that's how they will align of this is the real time somebody hits stop. When somebody hits stops, there's now a transactional piece. There could be a transactional payload that's associated with it that captures it all. So before I get into how HiveMQ supports this type of architecture, something that I really want to draw out and make sure that it drives home is that if I am now modeling all of my data based on a standard, because now the thinking is we're going to take all this UNS information and we're going to dump it into a graph database, you now know all of the relationships for every piece of data that's now down on your plant floor. So if I have my job order, I know its evolution from when it was a process segment, my definitions, work definition, my work master, all that information there. So when you want to build in a graph, so you build all your edges and nodes in that system, you already know that. You don't have to build that bespoke. It's already there for you. That's where this really becomes powerful, is on that AI/ML piece. Because this plant calls it a production order. This plant calls it a work order. These guys call it a job. Well, they're all the same thing. Now, if we have a standard way of approaching it, it doesn't really matter. I've abstracted it away. Or we're talking about all the resources, all the definition, all the schedule, all the response.
When you start this project, there's 3 different people. How do you decide which one's right? Where's that?
The standard tells us. Yeah, it's an operation schedule or it's a work schedule, depending on where that system is. Let's look at it.
We're running slightly over time, so.
Yeah. I thought I had till 12:30 because I had 11:30 to. All right. So we're going to since it's a HiveMQ thing, here's how HiveMQ supports it, right? So it'll do your telemetry data. It'll do your transactional data. You also have all of the extensions. So when you think about who do I want to use as my MQTT partner, guess what? It's a robust broker at its core. It's going to handle a lot of data. It can support transactional information, telemetry data, that type of thing. Now you have the new edge. Now I'm going to be modeling all of that, what I call asset, raw, edge data. We now have the ability to model all that through HiveMQ. So you have that. What are we going to use for our data ops, at least at that telemetry data? And of course, that's where the asset models come in. When you get into the data hub, now we'll be able to do some data validation to it. Keep in mind, this is not an orchestration piece, but there are some business logic. There's things that we can do that if that payload comes in bad, we can just report as an error, but that orchestration system doesn't have to handle that payload. We're going to clean it before it gets there. So when we talked about event-driven architecture, there's something known as command response query segmentation. This is going to handle some of that information for you. And then finally, when we have Pulse, we're going to be at the edge, be able to record all this information. It'll be able to do some machine learning because that now we're bringing in all of that information contextualized in real time. It also gives you the event context. And then from analytics, and I should say, going back to that event context, what we can do is that, say if I have continuous information and I now need to, let me back up. I'm doing a material movement, but it's through a pump that is continuous. I'm not going to continue to update how much material is moved. I'm going to do that over a period of time. I'm now going to use Pulse to go at, and last time I published in this last 10-minute segment, I'm now going to find out what's the min and max. That information is then going to get reported up to the ERP of I've now moved this material, or I've consumed this material, or I've produced this material. So right at the edge, we have the ability to do transactional information using some historical data that's of note. And then finally, the ability to do all your analytics and that type of thing. So, done.